Hey everyone. So a while back I had a video where I showed how to create a web API that could be used to load in an ML.NET model, and that was within an ML.NET end-to-end series. But with the increasing popularity of serverless, in this video I'll show how to create an Azure function that can make predictions. You can use that function within your other applications, similar to what you will use with that web API. Alright, so I'm in Visual Studio here. I don't have any projects loaded here, so I'll create a new project. And this is going to be a new Azure Functions project. And I'll call this just housing function. And this is going to be an HTTP trigger. And I'm going to use Blob Storage, so I'll browse my Azure account to look that up. Alright, I'm going to delete this function that's preloaded. And I'm going to add some NuGet packages. First things first, we install ML.NET using version 1.3.1 here. And for the Azure function, we need to install Microsoft extensions.ml. And since we're going to interact with Blob Storage, I'm going to download that as also. Alright. So now I'm going to add a new Azure function. I'm going to call this housing predict. Alright, and this, I'm going to take out the get because this is going to be a post. We need to post in some data for it to take in so it can predict on that data. Alright, so I mentioned I'm going to use Azure Storage. So if you look at my Azure Storage account with the Storage Explorer here, I'm in the models container and I have this housing model.zip. And real quick, let's actually look at the code that generated this model file. And here's the code that generated that model file here. The data I'm using is the California housing prices here. It has some attributes of the area and the houses within the area, such as latitude, longitude, the median age, total rooms, total bedrooms, the population of that area, and what we're going to predict is the median house value based on these other properties. Real quick, we'll go over to here. We load the text from data. It has a header, and we'll give it a separator. We generate the features, and we use some link here to do that. Within the data that we got from the text file, we get a schema, and with the schema, we can get the column name from there, and we just filter out where the column name is labeled, and it's labeled because we specified that in the housing data schema here. The median house value has the column name of label, and I don't use the ocean proximity here either because it's not a numeric feature column, it's a string column, so we'll do something separate with that. And we send it to an array. And then in our pipeline here, we featureize the text, the ocean proximity text, and we set it to a new column called text. And then we just concatenate all these features from up here to a column named features. Then we use the Poisson regression trainer, and we append that to this data pipeline, and then we fit on it, and then we just save that model out. And then we manually put that into our Azure Blob Storage. So with that, we first need to actually get a reference to that model file that's in Blob Storage. So to do that in the Azure function, I'm going to add a new class, and this is going to be kind of a startup class that runs every time our Azure function starts up. And for this to run every time the function starts up, we need to inherit from functions startup base class. So actually I forgot to install an additional NuGet package. We also need the Microsoft Azure Functions extensions NuGet package. And that'll have that function startup class that we need. There we go. And this requires an abstract class that we need to fill in called configure. And it gives us this functions host builder. And within here, we can start to build out our connection to the Blob Storage. And if you remember from when we created the project, we told it what storage to use. So in our local.settings.json file, it has this Azure Web Job Storage config setting, and it already has our connection string to our Blob Storage. So we can get that pretty easily here by using environment, get environment variable, and we can use that Azure Web Jobs Storage key that we just saw. And I'm going to put this in the environment variable target as process. So we have our connection string. Now we need to create the storage account using the cloud storage account. And we parse out the connection string. Now we create a client of our storage account. And then we get a container reference from the client. And that's going to be the models container. And we can get a reference to the actual model file from the container using the get blob reference, and then housing model.zip. And then I'm going to actually get the URI of this file. So model.uri.absolute URI. And here, this is where we use the ml.extensions from that builder that we get in the constructor up here. It has a services.add prediction engine pool extension method. And in here, I need to give it the input schema and the output schema. So we'll do that. We'll add a new class. This is going to be the housing data class. And I'm just going to paste this in so you don't see me typing in all this. Then I'm going to do the same thing for the housing prediction class. And this is just, I'm going to have a predicted price property on it, and it's going to have the call name as score for the ml.net engine. So I add these here. And then I can tell it either from an actual file, which you can use if you want to test this locally, but I'll use from URI. Then I'll just pass in the URI from the Blob Storage. Alright, so that's all we need to do for our startup. And what this does is that it creates kind of a reference. Well, first of all, it creates our prediction function. If you remember seeing in the previous videos, we create a prediction function, and from that prediction function, that's what we use to actually call the predict function. And so I'll go back to our function here, and I need to remove these statics because I need to add a constructor. And this is going to bring in the prediction engine pool for housing data and housing prediction. And that's going to be called prediction engine pool. And then above here, I'm going to create a private read-only field, which is going to take this same type and prediction engine pool. And then I'm just going to have the constructor set that field from when it gets passed in. So now we have access to the prediction engine pool within this whole class, and I can use it within this function. I'll go ahead and delete all of this, but it shows you how you can get information from either the query parameter or from the request body. And we'll be getting it from the request body. So I go string request body, and I need to await a new stream reader and do request that body. This is actually what part of that code that they gave you, and I'll read to end async. So next we need to parse our data that we got from the body. So we'll do JSON convert deserialize object into the housing data object, give it the request body string, and now we can get our prediction by calling the prediction engine pool.predict and pass in the housing data that we deserialized. And to return back a JSON object, we return a new OK object result and just pass in the prediction. All that looks okay. We can test this locally just by running it within Visual Studio. There we go, and it gives us a URL that we can use to test locally here. And to do that, since it's a post method, I'm going to use Postman. Alright, so here's Postman. I already have it set to do a post request, and I have the header as for the content type as JSON, and I'll just paste in that URL that it gave us in the output. And for the body, I'll do raw and set it to JSON. For the body, I'll just give it some kind of random values for our features that we have there, and we just hit send. Let's see, we get an error here. Unable to resolve service for type prediction engine pool. Well, we actually forgot something on our startup here. We need to tell this namespace to actually start up when the function starts up. So it doesn't know that by default. So on the top of the namespace, we do assembly, and we do functions, startup, type of startup. So now let's try this again. There we go, we get the same URL that we did before. So we hit send. There we go, now we get a predicted price result from that. So that's cool locally, but let's actually deploy this to Azure so we can use it in any other applications without having this function to run locally. So I'll stop debugging, and it's real easy to deploy this function in the project. Right click on it and hit publish. I'll create a new Azure app service for it, and I'll click run from package file. This basically zips up everything. I'll click publish, and it had already logged into my Azure account. I'll give it an app name, tell what resource group to go on, give it a hosting plan. I can tell it to do a new one if I want. I'm going to designate that same storage account that we used. Alright, and I'll click create. And this will probably take a few minutes to deploy everything. Alright, so our function got deployed here. Now I'm in the Azure portal with inside the function that we just deployed. And here's that housing predict function there. We can click on it, we can click run if you want to just test this locally. And we can give it that same body that we just did. And click run. It gives us that same predicted price output. But if we want to run this within another application, we just click this get function URL and copy it, and we go back to Postman here. Just replace that and hit send. There we go. We get the same predicted price output that we did before. Alright, so that's how you can create an Azure function and use ML.NET predictions to predict on a model file that you have already created. And we also went over how you can deploy and how easy it was to deploy the function to Azure. Alright, so thanks for watching, and we'll see y'all next time. Thanks.